Hello, and welcome to AP Daily. This is AP Physics C, Electricity and Magnetism. Today we're going to look at topic 9.1, electric potential energy. This is daily video 2 for that topic, where we're going to explore how to find the electric potential energy of a group of point charges. I am Michelle Strand. I am coming to you as an Einstein Fellow on Capitol Hill in Washington, D.C. So let's review. Electric potential energy, remember, is capital U sub E is going to be equal to K Q1 Q2 divided by R. And when 3 or more charged objects are present, you have to calculate the potential energy for each pair of objects and then add them all up, making sure that you use a negative value for any negative charges. So let's look at an example. So here we have 3 charges on 3 sides, kind of spaced out in a triangle. We are given the distances between them as just expressions, R1, 2, R1, 3, R2, 3, with no indication that they are similar or the same. So we want to derive an expression for the total potential energy for the system of the 3 charged objects. So what we have to do is identify what are the pairs. So the first pair I'm going to do is Q1 and Q2. And so the electric potential energy, I'm going to have to add all these up. So I'm going to have K times Q1 times Q2 divided by the distance between them, which is R1, 2. Next, I want to do 1 and 3. And I notice that there's a negative sign on 3 here. So I'm just going to pull that out front. And I'm going to have K Q1 Q3 divided by R1, 3. And then last but not least, I'm going to do the pair of 2 and 3. And again, noting that 3 is negative, so it's going to be negative. K, Q2, Q3, R2, 3. There's no way for me to simplify that unless I want to pull out a K, because the K is in every one. But I don't know that the charges might be different, the distances might be different. So this is my expression. So let's practice with this making a claim and justifying. So I have got 4 scenarios here. The distance between each of the point charges is the same. And I want to rank the systems from greatest or most positive electric potential energy to the least or most negative electric potential energy. The justify here, note that justify you can explain in words, or you can do sort of a calculation, which is what I'm going to do here. So we'll take a look here at A. I know I have to do these 2 pairs. We know that R's are all the same and the K's are going to be all the same. So I'm not worried about that. So really what I'm looking at here is just this product. So Q times plus 2Q is going to give me 2Q squared, right? And I can add a K over R, but I can pull that out too, because that's going to be the same for all. And then if I do these 2, I'm going to get negative 6Q squared. And if I do this, I get negative 3Q squared. And so minus 6 minus 3 is going to give me minus 9. 2 minus 9 is going to give me 7KQ squared over R. And that's negative. So I can do the same for the rest of these, right? If I multiply these 2, that's going to give me negative 10Q squared. I multiply these 2, that's going to give me minus 15Q squared. And then if I do these, it's going to give me plus 6Q squared. So negative 25 plus 6 is going to be negative 19. If I look at C, I'm going to have negative 3Q squared. Here I'm going to have plus 6. And here I'm going to have minus 2. So this is going to give me just KQ squared over R. And then for D, again, doing the same thing, I'm going to have plus 4 plus 3 plus 12. They're all positive. So that gives me 19 KQ squared over R. So now we can rank them. The most positive is going to be D. The next one that is positive is C. And then I want to go, my very last one should be the most negative, which is going to be B. And so A goes right here. So here's my ranking based on what they asked me to rank. My justification is all the work that I've done on the page to get there. So what should we take away? When calculating the electric potential energy between two charges, you will have negative electric potential energy when those charges are opposite, and you will have positive electric potential energy when you have the same charges. And that when you have more than two charges, you have to add up the electric potential energies between all the charge pairs. Hope that was helpful. Thank you and have a great rest of your day.